Let's review another hypothesis test when the population standard deviation is not known, using the p-value method. Once again, the p-value method is used when we have sample information and we're looking at the probability that we would get that sample average. So let's jump in. A politician congratulates herself in public that due to her policies, the average wage of service industry workers is greater than $16 an hour. You take a sample of 16 service workers. The sample average is 1525. The sample standard deviation is 220. You set your confidence level at 95%. We're going to create a hypothesis and test it. Now the politician has set the null hypothesis with her claim. That the average service industry is greater than, so we can go greater than 16. And our alternative is the opposite. So we will test equal to or less than 16. So to do this, what we are going to use is our formula. Our sample average 15.25 less our hypothesis average of 16 divided by our sample standard deviation of 220 divided by the square root of our sample size of 16. Now our degrees of freedom in this scenario is our sample size n minus 1. So here we have 16 minus 1. So our degrees of freedom are equal to 15. Oops. Our degrees of freedom, 15, so T15. And when we work out this math, we get negative 1.3636. Now, although we have a negative number, we don't use negatives in our t-charts. This can be converted to positive. So when we have a look at our t table with degrees of freedom set at 15, here we are, and what we're looking for is our result of 1.3636. And as we move along, we see it falls just after and in between here. Right. So when we have a look, you can go to the top here, and we see that it falls within this area. Oh, sorry, it falls in this area. So now this is a one-tail test because we're only looking for less than 16. We're not looking for not 16, where the average could be more or less. So we fall between 5% and 10%. So we know that the probability is 5% to 10%. So if we were to do this sample 100 times, we can expect that the probability of us getting a average of $15.25 would happen between 5 and 10 times. So because our confidence level is at 95%, which gives us a significance level of 5%, this happens often enough that we don't have the evidence to reject the null hypothesis. We can reject the alternative. Now, this is not saying that this is correct, but we don't have enough evidence to reject, to outright reject this. So we're going to reject the alternative.